Let's talk about adding and subtracting rational expressions. So if you think about adding fractions, essentially is what we're doing, but these have rational expressions in them. These have polynomials in them, excuse me, they are rational expressions that you need to have a common denominator to add two fractions or subtract two fractions. And that's what's happening here. So what we do is factor the numerator and denominator. Then we find the least common denominator of the expressions. And then multiply the expressions by a form of 1 that changes the denominators to the least common denominator. And then add or subtract the numerators and then simplify. So it's very much like we would work just regular fractions. For example, this 12 over x plus 15 over y. Our LCD is just going to be xy. So we have 12 over x times y over y. So y over y is just 1, so we're not changing the value, we're changing the appearance. And we get 12y over xy. And then we have 15 over y. That needs to be multiplied by x over x. Again, we're multiplying by 1, so we change the appearance, not the value. So when we have 12y over xy plus 15x over xy, we get 12y plus 15x over xy. And that's it. I think I stayed within the boundaries. I hope so. Let's get over that way a little bit. There we go. And for the next one then, I need to factor the denominator there. So that looks like a perfect square trinomial. So it's x minus 2 times x minus 2. And so that must be the common denominator. So I'm going to multiply the second one by x minus 2 over x minus 2. So what we're going to have is 10x over x, well, no, let me leave it factored, over x minus 2 times x minus 2 plus, now I distribute this 4 across the x minus 2, 4x minus 8 over x minus 2 times x minus 2. So we have 10x plus 4x minus 8 over x minus 2 times x minus 2. And that simplifies to be 14x minus 8 over x minus 2 times x minus 2. And that's about it. Okay. And we have another one. We're going to do some subtraction. So here we have 3 over x plus 5 minus 1 over x minus 3. These are just different denominators. So our LCD is going to be x plus 5 times x minus 3. So we have 3 over x plus 5 times x minus 3 over x minus 3 is 3x minus 9 over x plus 5 times x minus 3. And then we have, I need to manage my space here, 1 over x minus 3 times x plus 5 over x plus 5. So we have x plus 5 over x plus 5 times x minus 3. So now they're both in a common denominator format. So we can look at 3x minus 9 over x plus 5 times x minus 3 minus x plus 5 over x plus 5 times x minus 3. So we write these over the same denominator. I'm going to do it, well, so 3x minus 9, distribute this negative here, minus x minus 5 over x plus 5 times x minus 3. So we have 3x minus x is 2x. Negative 9 minus 5 is negative 14 over x plus 5 times x minus 3. And we could factor a 2 out of the numerator, but it's not going to do much. I mean, if you want to go there, 2 times x minus 7 over x plus 5 times x minus 3. But they're both acceptable answers to me. And for the last one for this part, we have x minus 5 times x plus 5. So our LCD is going to be x minus 5 times x plus 5. So we have 12 over x minus 5 times x plus 5 over x plus 5 to give us 12x plus 60 over x minus 5 times x plus 5. Then we have a 7 over x plus 5 times x minus 5 over x minus 5. Remember, that's just 1. So we end up with 7x minus 35 over x plus 5 times x minus 5. Now we put it together. We have our 12x plus 60 over x plus 5 times x minus 5 minus 7x minus 35 over x plus 5 times x minus 5. You scroll up a little bit. And that's going to give us, remember I had to distribute this negative across these two terms. So I'll have my 12x plus 60 minus 7x plus 35 over x plus 5 times x minus 5. And 12x minus 7x is 5x. 60 and 35 is 95 over x plus 5 times x minus 5. And you could factor out a 5. It would be 5 times x plus 19, but it's not going to take us anywhere, so take that answer. Okay.